Okay, so we're going to go ahead and make sure instead of the particles emitting from everywhere on the stick, we only want to emit them from where, at least starting from where it's being ignited from a null. To show you how that works in a simple example, we're just going to add it to the point cloud first of all, and then we're going to show how to use the stick to actually make sure that actually it ignites, stays alight, and burns up through the stick. So we're going to start with a test inside null. And you can always do tests and see all the different tests, and we see a test inside null. We need a null, so we can pick our null from the scene, hit F3, and drag and drop it into the ice tree, and link the out name, in this case, to the null name. Or you could just type the null name inside the test inside null. Now we have this, we need to decide what's going to happen. Well, we want to delete the particles, or we use the delete point in this case, if they are not inside the null. So right now this test inside null, so we need to know whether it's not inside null. So we'll just use those conditions. If you look under all the different nodes, under tools, there's all the different condition nodes, statistics, and comparison, and there's not equal to, and there's also a basic not node as well. I believe it's under math, but normally there is a logic node not. Or again, I would just type in not. We hit the not in to value and then out to the delete point. And then what we happen here, we get a null, we test if it's inside the null. If it's not inside the null, we delete the point. It's almost like a little sentence. And then we bring this delete into one of these execute on emits, because we're dealing with stuff at emission time here. So using execute on emits is a good way of doing this. When we hit play, we will see it's only emitting points when they're inside the null. We can look at this as well by visualizing, and we'll see right mouse button show values. We'll see there's zeros here because it's not. But if we check here and we visualize there, show values, and I'll just hide these ones so we're not looking at both. You can see it's ones inside the null. We did not make it zeros. Okay, so that's working well, but there's a slight problem, and that is as I move this around, it's not actually setting the stick on fire, it's just emitting from the null. If I move it off the stick, the particles stop, on the stick, they start, off. So it's not doing exactly what I want yet. So instead of putting this on the stick directly, we're actually going to set something up on the particles directly. We're going to put this effect on the stick, test the stick, and then feed those values back into the particles through a few different nodes. So for a moment, I'm just going to unlink this one, and we're going to go to our stick. And we'll see there's no ice tree on here. We need to set up 2 ice trees for this effect to work. The first ice tree is going to initialize the effect. Just know that I had a little bit of history on there, so I'm just going to delete the history from the stick. You never want any history on an object you're creating ice trees on, just to keep everything clean. So we're going to create an ice tree. It goes under modeling, and we're going to initialize the value. We're going to do that by getting data. We'll get a set data, and we're going to set a new data value, and we're going to call this self, because we're going to be on the object self, and I'm going to call this burn. And we have a new burn value. Now I want to set it to a certain value. So if we want to, the moment it's just coming in, but it's not set to anything. So we could do a scalar and we set it to 0. If we were to visualize this, there's going to be a slight problem. It's just per object. And I want this per particle. So the way we can do this is use another node that exists on any geometry particle or geometry point, and that's point location. So we're going to get data, and we're going to do a self dot explore, and we're going to see here point location. And I find this really useful when you want to change something from object data to point data. Now that's just point location. We're going to do another get data, and we're going to get again self, and if we explore we actually see the burn is on here now, self.burn. And because I fed a scalar into it, it's a scalar value, we're going to take this into source, it turned red, that's because we don't need a self anymore. And what's happening here is looking at every point location by using the point location. I did point neighbors by accident. Point location. Don't pick the wrong one. So point position, point location, there we are. Now it's the right one. So point location, and we can just feed this in to self-burn, and we can show values, and they're all 0 now. Because I put the scalar in first, we'll kind of set it to scalar. You can also then add value if you want to change it from 0 to 1. But now we'll set those all to 0. So it's a great way to initialize using the point location, using a burn node. You can see here there's a custom node, and setting the data back, and you can see they're all set to 0, so that's been initialized. I'll hide this value, and I can rename the ice trees if you want, and I can call this init ice tree, so I know that's my initialization one. Now I actually want to create the effect, so we're going to create a simulated ice tree. The reason we want to simulate it versus just a basic ice tree is if I move this, I want those points to stay set to 1. So we create a simulated ice tree, also on the stick, and this is the one that's going to do all the work. And we're going to get a test inside null, we're going to get some get datas and set datas. Often you're getting and setting data when you do this. We need our null. So F3 and drag and drop. Hook the null up. Out name into null name. The get data we want to get our new, actually we should do self here. It's always good type self. Explore. And we want to get the burn. And we're also going to be setting the burn. Self dot. Okay, so we've got most of the nodes we need. We're going to need a couple more. We're going to need an if, because we've got this test. We need to what do if the test passes, and if it's true, if it's inside the null, we're going to set its set data to a value of 1. To set a value, of course, we're going to use a scalar value, just a scalar constant, and we're going to set that to 1. So that's great. If it's true, it's going to be set to 1. Let's see what happens here. Let's preview this in a second. Now, to actually look at these numbers, if I just looked here at the 1, show values, and hit play, you're just going to see the 1 again per object here. That's because we're just looking at 1 here. We haven't seen it after it's been set. So if we go here and get another set data and use this one here, in this case we're going to do it if it's false, just kind of set the data on everything, and let me just go here, show values. Now we can see at the moment it looks like everything's 0. Again, we're looking too early on in the ice tree to see those values be changed. It's one thing when you're looking at values, it doesn't know this has been set to 1 because we're looking in the same statement. So what I often do is just for debugging, I just copy these and paste it and just hook it in to the next port. Turn this one off, and if this works, you see those are set to 1. Now if I move this, because it's simulated, they stay at 1. They don't go back to 0 if they would if I had it as a non-simulated ice tree. And the reason they stay at 1 is because I'm doing a couple of things here. One is I'm setting them to 1 if it's true, but if it's false, I'm setting it back to its whatever value it was previously. So it stays at 1. And I'm just using this node here just as a debug node, just to see what's going on. It's not being used to do anything special. It's just so I can see those numbers and if they're changing, if everything's looking correct. And I just may leave it in the graph for a moment, and then I'll remove it later on when we get to the final cleanup stage. I'll just hide those values. So the final step to make this work is go back to our particle ice tree. So we now have some values set on our stick, and our stick has these values of 0 and 1. And there's a great node to get the values from another object, and it's this get particle emit location. Just like the location value I use to set everything to 0, so it's per object, this just looks at where the particle was emitted from and says what is the value at that location. So you can get different information from that. So using a get data, I can link the location into the source and explore, and it's looking right now. See, it's burn. It sees the burn because the burn is on the stick, and it's looking at the stick location, the emit location, so from the emitter object. So when I have a value here, we can do a quick if, and we can do a test. Actually, we don't actually need the if statement, so I'll remove the if statement for a moment. Just do a test, and we'll say if the value is less than a certain value, so we'll say 0.1 for instance, then delete the point. Very similar to the previous one, but the test inside null is done on the stick now, and we have this test here. We'll hook this into execute on the emit. So it's saying that if any points are less than 0.1 or close to 0, delete the points. Let's see what happens. Particles emit from there. If I move the null around, now they will stay emitting from anywhere the null hits the particle. So you can see how I'm igniting things. And there's a lot less particles right now you're seeing. And the reason for that is it's because we're deleting lots of the particles. So you may want to actually increase your rate. We're going to go up to 500. And we may want to decrease life or speed or the forces. You'll see now we've got this nice, turn that grid off because it's in the way. Some nice effects of this burning as I move it up, and I can move it off and maybe light the top a bit. I have to make sure it's actually touching. Of course I'm working in perspective here, so let me just get it on that, and you can see here I just got the top there also ignited. So that's working great. We have our igniter set up. The next thing we're going to do is set up the ways to have the burn spread along. So at the moment, if it hits the object, it's just going to start burning from that one point. But it's actually not going to spread up, it's going to just stay burning from that one point. And if it was actually fire, the fire would spread along the surface. And that's what we're going to create next.